Alright, so here we go. Let's go and take a look at questions 1 through 5 here in this first video. And the directions for this section are find the greatest common factor, aka the GCF, of the terms. Alright, so if we take a look here at number 1, we're given 21 m to the 4th and 189 m to the 7th. And since they just want us to find the GCF, what I always do is I always start with my number, because what we're going to do is we're looking for the largest number that goes into 21 and goes into 189 evenly. All right, well, let's see. The largest number that goes into 21 and 189 evenly is actually 21. 21 goes into itself 1 time, and 21 goes into 189 9 times. All right, so now that we've taken care of the number part, now I move on to the variable part. And we're going to do the opposite of what we did with the number. So with the numbers, the coefficients, what we've done is we've taken the largest coefficient, the largest number that goes into each of our coefficients. But now that we're dealing with our variables, we're going to take the smallest exponent. Well, we have the same base, m and m. All right, well, what's smaller, 4 or 7? Well, obviously 4 is, right? So we're going to take out m to the 4th. And so 21 m to the 4th is our GCF for number 21. Let's take a look at number 2. We've been given 10 m to the 5th, 40 m to the 9th, and 100 m to the 6th. All right, well, again, let's go ahead and just start with our coefficients. Start with these, just our numbers. And we're looking for the largest number that goes into each of these coefficients evenly. Well, let's see. Does 2 work? Yeah, 2 works, right? 2 goes into 10 5 times, 2 goes into 40 20 times, 2 goes into 100 50 times. But is it the largest number? Well, no, it's not. So let's not work with 2. How about 5? Well, we know 5 goes into each of these, right? Because each of these numbers ends in a 0. But again, is it the largest number? No, I don't think so. However, how about 10? Well, 10 goes into itself, certainly, 1 time. 10 goes into 40 4 times. And 10 goes into 100 10 times. So there we have it. Our number is 10. All right, so now that we've dealt with the number, let's go ahead and deal with now the variable portion. And again, we're now going to, since we're working with the variable, take out the smallest exponent. So we take out the largest number, but the smallest exponent. So here we have m to the 5th, m to the 9th, m to the 6th. Well, which exponent is the smallest? Well, certainly m to the 5th, right? 5 is the smallest out of 5, 9, and 6. And so there we have it, 10m to the 5th. All right, let's take a look here at number 3. So we have negative 21 AB, negative 24 A squared, negative 30 AB squared, 18 B squared. All right, well, let's go ahead and just like before, let's start with just that coefficient, our number here. And let's see, well, 1 obviously goes into each of these things, but we don't want to use 1 because 1 will be common for every single thing, right? Because 1 goes into all of our numbers. So that's not what we want to work with. How about 2? Well, let's see. 2 goes into 18, 2 goes into 30, 2 goes into 24. Oh, but 2 does not go into 21, so that's not going to work for us. How about 3? Well, let's see. 3 goes into 21 7 times. 3 goes into 24 8 times. 3 goes into 30 10 times. And 3 goes into 18 6 times. So I think we found our number. So let's go ahead and take out a 3. Now, we could have taken out a negative 3 if this was a negative 18, because then each of these numbers would be negative, and we could have pulled out a negative 3. But because our 18 here is positive, let's go ahead and just take out a positive 3. All right, so we've taken and dealt with our numbers. So even if you want to cross those out, just to help you focus now on just the variable portion, that's perfectly okay. So let's see. Let's just deal with the A. Let's see if A is common in everything. Well, it's just, I underlined b, but we can clearly see that a is not common in this last term, this 18b squared. So a will not be a common factor. It won't be a GCF. So we can ignore the a. Well, how about b? Is b in every single term? Well, we have a b here. Oh, no b here. So we can go ahead and stop right there because, remember, in order to be a common factor, that c part of the GCF, greatest common factor, it has to be present in each and every term that you're working with. So as soon as we get to this second term here and we see that there's no b, well, b then is not going to be part of our GCF because it's not there. It's not common in every factor. And so that's it then. 3 is going to be our GCF for this term, or rather this string of terms. All right, number 4, let's take a look at. We have 315 x minus 3 quantity cubed, and then we have 63 x minus 3 to the 6th. Well, let's see. Let's not let, now we're starting to get into some bigger numbers here, and now we're seeing parentheses and a binomial raised to, different powers, but let's go ahead and just take it step by step, just like we did with these first few here. So we're just going to deal with our number first. And if you were to, you could use your calculator certainly, but you will see that 63 certainly goes into itself, and 63 goes into 315 5 times. And so 63 is going to be the number that we pull out as being part of our GCF. And now we're going to, since we've dealt with our coefficient, we've dealt with that number, we're going to move on to the power portion, right? So, and because we are dealing with a power that is being raised with something in parentheses here, you can really think of this quantity here, this x minus 3, as a single term. So this would, really be no different than saying 315 x to the 3rd and then 63 x to the 6th. Because we have parentheses here, this exponent has power over the whole quantity, and so this really acts as one term. And so we can see then that this x minus 3 is in both of our terms here. So because we have parentheses around this quantity and it is present in both terms, that acts as a single factor. And so let's see, we're going to use that rule again and take out the smallest power. All right, well, we definitely know we're working with an x minus 3, and if we look and we see a power of 3 or a power of 6, which one is smaller? Our 3. And so there we have the GCF for number 4. All right, and then finally here, number 5, we have 2d to the 5th, and then the quantity f plus g to the 6th power, and then we have 19 d cubed times quantity f plus g cubed. All right, well, let's go ahead and take it step by step again. Let's just deal with our coefficient, that number. Well, we have 2 here and a 19 here. Is there any common factor between 2 and 19 other than 1? No, right? Well, if there's no common factor between your coefficients, well, then there's no common factor, so you don't have to pull anything out because you can't. All right, so we've dealt with our coefficients. Let's go ahead and move on and take a look at the next variable here, and we have d to the 5th and d to the 3rd. Well, they have like bases, right? They're both d's, and so which exponent is smaller, 3 or 5? Well, 3 is obviously smaller than 5, and so we'll take out a d to the 3rd, and now we can say that we're done with that d. And now, just like with number 4, because this exponent has authority over this whole quantity here, because it's in parentheses, we can pretend that this f plus g is just a single variable like x or y or whatever letter you want to use. And so again, we can look at our power, our exponent, and say, all right, well, is 3 larger or is 6 larger? Well, 6 is larger, and we know that when we're dealing with powers, exponents, we want the smaller number, and so we're going to take out f plus g to the 3rd. All right, so again, when you're dealing with your coefficients, those numbers in front of your variables, you want to take out the largest number and then take out the smallest exponent. All right, largest number, smallest exponent. All right, there you have it, 1 through 5. All right, and we're moving along here. I will see you in the next set of questions with video number 2. This is Joe Brownlee with Palm Beach State. Thanks for watching.